Okay, so the first thing we want to do is come up here and want to, oh, that's odd, huh? It's missing. I click here. Oh, maybe some formulas going on. Wow. What is that all about? Now it works. Let's try again. Zoom to selection. Oh, look at that. Isn't that weird? And just to make it a little bit easier to see. Okay, so notice that I put up there our standard equals our experimental, about 100 ohms. Okay. And that is weirding me out big time. I don't know why it's doing that. What happens if we 273? Let's try 200%. That is supposed to say ohms. Okay, and that's 100 ohms. Now we have a table up there, and so the first row, if there's just so many inductors over there, so at the moment I've got the 2.7 times 10 to the minus 3 henries, and it says to use from 0.2 to 1 times 10 to the minus 6. So 0.2 times 10 to the minus 6 is 2 times 10 to the minus 7. All right, so that's just entering numbers. And now this, I put that up there. It's not up there at the moment. The resonance frequency pi times the square root of LC, and this is in henries, and this is in farads. So that's why I have the exponents up there. It's because a lot of times you would just say 2.7 millihenries, and that's fine for humans, but the math needs it to be a certain way. So now I know my resonant frequency, depending on what LCs I type in. That's a good thing, because remember I said we want your resonant frequency to be 2,000 to 8,000 or so. So this way, pick your inductor first, whatever you find up there, and then grab a capacitor, and then type in their numbers and see if you picked well. Okay, now this spreadsheet is our estimator, but once we've done this, we can just copy it and type in our real data. We're going to assume that the math that I gave you is correct. Who knows? So you'll notice here I've typed in a series of frequencies. That's 30,000. That's 100. So 9 minus, so I got 20 frequencies. So for now, you just need to populate 20 slots with something like this. So you notice it goes 100, then I skip to the thousands, and then the 10,000s. It's not important if you get it exactly the same. Some of them in the hundreds, some of them in the thousands, and some of them in the 10,000s, and go up to about 20,000 or 30,000 like I have. Okay, so get this going on. You know how you can change. I don't know why this is happening. Oh, right, because I had this formula open up here. You can change the size of the row by selecting the whole thing. See how the cursor changes? Also, I picked the 3 cells, and then I went up here to layout, is it? Or is it just home? Yeah, merge and center. That's what I did here. I picked the 3 cells, merge and center. So you see CRL. It doesn't matter the order, it's up to you. It's maybe easier to copy me, of course. And then you see the V out, V in. And then this is what you're going to calculate. The Z of that element, the Z of this element. So work on getting your 20 frequencies and the labeling you see here. All the way to LC. Oh, sure. Can you see it? It's the same as up on the board there. It's just in Excel speak. That's all. So right, you have the table in the printouts. So you just want to populate it for now with the frequencies, the CRL across the top like that. I mean, if you're not confident about merging cells, don't worry about it. And then the V out, V in, and the Z's like I have. Get that going on. I'll pause the recording for a moment. It's ticking again. So I just typed in a V in, and oops, excuse me, I got to hit escape first. In fact, if you wanted to, you could put in 1 here for V in. I had an idea about something else. I put 2.5. So all the V-ins should be the same, at least in a column. I made every blessed one the same. 2.5, 2.5, but you could just as soon make it 1. That's not a problem. So once you've got all the headings, you've got 20 frequencies, fill in the V-ins, and all that you care about for now is that you make the columns the same, every one in a column the same. If you make every blessed V-in the same, that's okay too. All right, I'm going to get the next one up there, and look at that scary mess, huh? This is just like we did before on those slides. What we have here, oh no, I want to draw a menu. Here we go. Oh, interesting. I have to add the draw menu, I forgot. Well, I can't write on it. Okay. So there's a slight difference in what we were writing on those slides. And it's just this. Because remember, I'm doing V out. So that equals Z2 over Z1 plus Z2 times Vn. And that is the E9 right here. Because I could have just set it up as V out over Vn, but since we're going to be measuring the two things, I wanted to set up the spreadsheet to look like the data table. So you see 1 over 2 pi times C9 is frequency, and D4 is the capacitance. Notice the dollar signs. Because you need it to, that's absolute referencing. Has everybody seen the dollar signs before? It's called absolute referencing because we need it to reference that box over and over again. For the moment, just enter it the way you see it. And I suppose, to be fair, I'll get it back. You need to see the, oh, it's not, the numbers don't show up on the left here. I don't know why. Okay. So this is row 9. And you can also see, like, D4 is red, it's highlighted. And D5 is our standard, it's highlighted too, it's not showing up very well. Time to pause. And then we have to multiply it by Vn times, and that's obscured, but I know that happens to be E9 because I have the E up here on the top, so I can just manually type in E9 without clicking on the box itself. And then here's a feature you may not know about. If I go to the lower right-hand corner, you see a little square. Watch the cursor changes. And I can just drag it down. It's called the fill handle. So what you guys would have had is this. So I've got the 1. And then I just drag it down. And there it is. So I'll put that one back up there for the time being. What is the formula I just typed in? This one. Yeah. I just didn't do the square and square root on the numerator. Yeah, I wanted to write that on the screen, but I haven't set up Excel yet to write. It's a new install. I'm going to use my drawing tablet. So you're setting up, and there you see the V in there. That's what strictly speaking, what I did. So that's what we just were doing in the spreadsheet. We set up the V out for the RC circuit. Got it? Okay. Then here is the V out for the R. That one's very easy. Lots of dollar signs. And the recording is running. Yay. Correct. If dollar sign to D means it stays in the D row, dollar sign to the 2 means it stays, the D column and the 2 row. You can have $1 sign on either the D or the 2, but in this case we wanted to pick exactly that same number each time, so that's why I used $2 signs. Is that answer good? Sometimes, in this case you could get away with only 1, but it's safer to use 2 in this case. What'll happen is, as you get more sophisticated, you'd say, oh, well, you know what? I know I'm going to be repeating this slightly to the right, so maybe I'll only dollar sign one of them. But this is not a case, because each one of these V outs is so different, we can't do that. Well, and it's very hypothetical what I just said, and I wouldn't spend many CPU cycles trying to figure it out. But we need to, because I want you to do this, but I'm hoping that you realize that spreadsheets are really powerful. They really can save you a lot of time. There's certainly a startup cost, right? It takes a while to set up your first couple of them. But then you can, especially with these RLC circuits, you can do a lot of copy pasting once you've got it done once. And the other trick is that block I made at the top left, where I can just punch in my values and the whole thing changes for me. That's the most powerful feature of a spreadsheet. Okay, then the next one is the RL circuit. This one's easier because there's no 1/overs going on. So 2 pi times the frequency C9 times D3, which is L. So that's 2 pi FL.
What's your H9 in here?
H9 is the VN. Yeah, I just did it this way because it looks more like the data we're taking today. In general, if you were to do this as an exercise, you would probably set all the VNs equal to 1, so basically we'd be calculating V out over VN. But again, since it's our very first time, I want it to look like the measurements we take. And then this table you can copy it and use it for your data analysis when you take the data. With a few changes, but I'll walk you through those too. So if you look at it, you have the Z of the inductor divided by the square root of the resistor squared plus the Z of the inductor squared. And then I just multiply by Vn. Which one? The resistor. Sure. So this one doesn't have any adding and quadrature, which is nice. You're welcome. Anybody want the L again? The V out for L? I'll just get it for a moment. Got it? Yeah, take your time and get it in there because we can't proceed unless you have it typed in. Of course, if you don't have a computer, I'm sorry if I hadn't reminded you of it. But again, from now on, always make sure you have something like that. And by the way, the university has, if you only have a desktop at home, the university has some Chromebooks to be lent out. It's always a good idea to have something. And even so, if that's a problem, I have computers we could set up in here. It takes up room though. We could probably put the CPU box on the floor. You see, I have the whole room networked. I just left the computers out this time, because usually people have their own. Okay, so now the hardest one of all is the LC circuit. Ha! Look at that mess. Let's see if I can linearize it a little more. Okay. So now you can see the inductor minus the capacitor. Now the numerator has to have the adding and quadrature. Well, does it? I don't know. I do it just because I worry. I suppose it doesn't. We did it on this slide. The PowerPoint slide, we didn't do it, but I just feel better. Yeah, I guess what you do, if you took a picture of this, you could then have it in front of you while you're staring at your spreadsheet, right? Oops, should pause this. Bad. I didn't record that. So let's take a look. Why doesn't that come up? Oh, I have to hit the escape key first. 100%. So now we've got this table. Somehow I lost the outer border there. It's too bad. And you can do things like you can format the numbers. These don't need to be scientific notation, because they'll be, we're reading it off the oscilloscope, so the most we'll get is probably 2 decimal places. The sign out's good for the impedances, though. Right. Alright, so now we're ready for the big leap. Unless somebody needs me to highlight one of these cells again to get the formula right. Anybody? Which one? V out for LC? Okay. Oof. That doesn't look very readable, does it? Let's see. Oh, there you go. That's better. You see the fraction line is right here by the cursor. I mean, one way to do this is to make subcolumns, but I wanted it to look like the data table. That's the only drawback of Excel. It's very visual, but it's still like a command line operating system.
Why is 2 pi FL not squared, but 1 over 2 pi
Um,
S?
oh,
Oh, I see.
okay. Because it's LC, right? You have to square the two of them added together, which happens to be with the minus sign. Oh, man. Oh, of course now it's recording when I don't. And so I select all these. Now here's the trick. Hold down the control key because we want to plot all the inductance, the impedances. And this is called non-contiguous selection, and you do that by holding the control key down. Now this is one of the few times that when you graph data, you actually want to connect the dots. Insert, scatter, and it's the one with the curved lines, not the straight lines. And there it is. Doesn't look like much, does it? So if we go click here, if you have does anybody have a Mac? Yeah, okay, so I have to show you how to do it in your Mac. If you double click on the graph, then the bar will appear on the right. For PC users, all the elements that you want to work on are going to be here. In the case of the axes, I believe in a Mac this will work. I just go click on the axis. If not, you have to come up to the top here, Chart Design, and Windows has it too. If you go to Format, the drop-down box is over here. For Windows users, you have it here, and you have it in this box on the right. And we want to format the horizontal axis. And want to pick the bar graph icon, axis options, and want to make it logarithmic. At least I thought that's what I wanted to do. Oh, I got it. That's fine. Well, let's do the other one too. So I go here, and now because I had this up, as soon as I click on the y-axis, it's right there. And let's look at that one. Ooh, I like that. Maybe it's this one I don't want logarithmic for the time being. All right, well, we can make both of them logarithmic. So we should see something like this. Now notice, it's very asymmetric. So maybe we don't have to go down to 200. It looks like if I want the 500 here, and then maybe make this one 1,000. If you collect both of them, it should go up by 500s, yeah. Aha, well that worked out pretty nice. And in this case, we're done. And I might want to trim some off the bottom. But let's go back to what I had for a moment. One thing you'll also notice, there's a crossing point. And the crossing point looks like it is about at 6,000 or 7,000. So let's take a look here. Let's type in the resonant frequency here, 6848. Whoa, look what happened. But now we notice that we don't have very much at all on the left side. So maybe I want to put 6848 here. Okay. Still don't think I'm delineating it very well. So there's no set way of doing it, but I get the feeling like I've got 20 numbers. So I'm going to go up to about the middle, right here, 68448. Okay, that looks pretty funky, but let's just start going downwards. 5,000. And let's say 4,000. 1, 2, 3. Now if we select those two, take our fill handle and go down, what happens? Okay, and that's still looking funky. Trying to think of a good way to, because you know what's going to happen is, okay, you guys are not going to have any numbers there. And what did that do? It gave us a divide by 0. It's not working out as nicely as I thought it would. Oh, okay, so here's the original one. So I guess the way to do this is to start out on the left and say, look, that's too low. So I see that with symmetry on the left and right, it looks like at about 1,000. Okay, so let's try making that 2,000. And if I select both of them, now I'll do the fill handle. Okay, nice, that's looking nice. So I know I'm picking up my resonance. Sweet. And it looks like I got a lot of points there. So here, maybe I want to do 15,000. And then I select these two. and it's going to go up by 5,000 each time. Look at that. See how beautiful that is now? And maybe I don't even need 20 points anymore. Maybe I'll just nuke these guys. And look at how nice and symmetric that is. Now another thing I can do now is I can have the graph start at, instead of 1, I can have it start at 1,000. Sweet, huh? So you see how I've roughed it all out now. I have lots of, and I might want to reconfigure it. Oh, you can't see that. Where at the resonance here, I might want to add more points. But if you took data like this today and made me a graph, I would be ecstatic. So now look what we do. We've got this, we've got the graph, everything is ready for us, right? We've figured out the frequencies. You come down here, whoops, pay no attention to the man behind the curtain. How do I get, here it is. So there's our tab. Go right mouse click, move or copy. See the spreadsheet, like I said, I've had this going on for like 30 years. Create a copy, move it to the end. Now, we take all these V outs and V ins, and it's going to complain. And now it's ready. So now you take your measurements, you write it down in that table, and then you type them in, and presto, changeo, it's there. Pretty nifty, huh? And I had it recording too, thank you. Oh man.